Before we get to today's show, I'd like to mention that although ID the Future is free content, it's not free to produce. If you're enjoying the interviews, commentaries, and readings you hear on the podcast, would you consider partnering with me to create more new content next year? Discovery Institute depends wholly on donations from people like you who are excited about the work we do. Become an ID the Future partner today to help us produce new episodes and expand the reach of the podcast. Support the ID the Future podcast directly by going to idthefuture.com and clicking on the donate button at the top of the page. That's idthefuture.com and click on the donate button at the top of the page. Thanks for your support.
So we really see how like the fundamental forces of nature, just in their qualitative structure, not the quantities, the qualitative structure of these laws are designed in order to produce a complex universe with atoms and molecules and stars and life. And that really shows you why are these laws the laws of nature.
ID the Future, a podcast about evolution and intelligent design.
Recent scientific discoveries have shown that the laws of nature that govern our universe are finely tuned. But beneath these finely tuned numbers lies an even deeper mystery: the laws of nature themselves. Why these laws and not others? What is special about these rules that structure reality? Welcome to ID the Future. I'm your host, Brian Miller. Today, I welcome mathematician Ellie Feder and physicist Aaron Zimmer, hosts of the Physics to God podcast, to discuss their recent work explaining the uniqueness of the laws of nature and why they are the way they are. Welcome, gentlemen.
Good to be here, Brian. Thank you.
Nice to be here.
Now, previously, you've been interviewed by us, and you've talked about how the laws of nature are finely tuned, which suggests that they're designed. Now, in your recent podcast, you give a very different argument, but related. Could you please explain your new argument?
Sure. So our new argument is not based upon the numbers. The previous one was based upon the fact that the numbers, like the mass of an electron, the fine structure constant, that those numbers are specifically tuned to be able to result in our universe. Now we're not talking about the numbers themselves. We're talking about the laws of nature, the very underlying laws like quantum mechanics and general relativity. And the idea is, what is the cause of these laws? Why do we have these laws? Why does our universe work by these laws and not by any other set of laws? And that question really opens up a new path to see an argument for an intelligent cause of the universe.
Yeah, just add one thing is fine tuning was about quantities, how strong the attraction between forces is, how heavy something is, quantities. The new argument is about qualities, just the very qualitative nature of the laws, the fact that gravity attracts, disregarding how strongly it attracts, just the qualitative nature of the laws.
As a physicist, I really appreciated this approach you had in your podcast. Now, you had mentioned that this relates to something called the quest for a theory of everything. Could you explain that quest and why it's relevant to our conversation?
Sure. So really, it's the quest for a unique theory of everything that has really grabbed hold of physicists' imaginations and their dreams. Nobel Prize winner Steven Weinberg wrote a book called Dreams of a Final Theory. And the idea of a final theory that's unique. Unique means that it will be impossible for the theory for the laws to be any different whatsoever in any possible way. So, for example, the dream was to discover one law of nature that would explain everything else in the entire universe. And they would be able to show, these physicists would be able to show why it's unique. It couldn't be different, either because logic would show that it has to be this way, or mathematical consistency would demand it, or any change in the law would result in an infinite energy, certain things that are physically impossible. And then physicists would be able to say, the reason why the laws of nature are exactly this law and no other law is because it would be impossible to have any law that would result in a physical universe for any other way. And then we would be able to understand, why are these the laws of nature and not something else?
I just want to clarify one point. There's like the background question of this whole thing is, and at least Mullen expresses this, is that we try to explain everything in our universe, and we ultimately explain them based upon the laws of physics. But the question is, why do these laws themselves exist? We could have imagined many different other possible sets of laws, and that's what Smolin says. Like, the thing which is most in need of an explanation is the very laws themselves. And if we don't explain that, then we haven't ultimately really explained anything. We're ultimately pushing everything back to these laws. But why these laws? And as Aaron mentioned, if scientists would discover there really is only one possible, logically consistent set of laws, then they would say, oh, that's why these laws, because there's no other laws which are possible. And that was the dream and the hope that they would discover such a realization.
Well, how successful have they been in finding this unique theory of everything, and how is that relevant to your arguments?
So they haven't been successful. It's basically physicists have realized that I think Paul Davies discusses this, and this is well known, that there's many other ways to model different laws of the universe, which are perfectly mathematically consistent. There's no reason why these laws are the only possible laws. It's clear that there are many, many other sets of possible laws which the universe could have been governed by. We can model them on our computers, but that's not, our universe happens to be governed by one set of laws. And therefore, the question returns, this dream to answer the question of why these laws by finding that these are the only possible ones is a failed dream. And now we're stuck with the question, why these laws and why not any other laws?
Oh, that's really fascinating. And you, in your podcast, talk about several examples of how the laws have to have a certain structure for life to exist. Could you share some of those examples?
Okay, so basically, it's on our podcast. We're trying to answer that question of why are these the laws of physics, the laws of nature, as opposed to some other laws. And once you show that there's no logical necessity, physical necessity, why these laws have to be real, as opposed to any other ones, then you start thinking in a different direction of why are these the laws of nature. And that shows you in terms of not like logical intrinsic necessity, but in terms of what is special about these laws. And you realize that if these are the only laws that we can know of, we can test out all other types of logical laws, but these laws are specifically designed, there's special laws that only these laws lead to a universe which has order and structure and complexity. So, for example, gravity as an attractive force. Again, we're completely ignoring quantities. That's fine tuning. It's a different argument. But just gravity is an attractive force. If you don't have gravity to pull masses together, there would be no such thing as stars or planets or galaxies. If you didn't have electromagnetism, which is, causes opposite charges to attract, then there would be no such thing as, again, stars. There'd be no atoms. There'd be no molecules. And of course, if there's no atoms and molecules and stars and planets and galaxies, there's no such thing as life. So we really see how like the fundamental forces of nature, just in their qualitative structure, not the quantities, the qualitative structure of these laws are designed in order to produce a complex universe with atoms and molecules and stars and life. And that really shows you why are these laws the laws of nature? Because they're designed this way for a specific purpose in order to produce a universe which has interesting things like stars and planets and life as opposed to an other random set of laws. I think Paul Davies calls some ragtag bag of laws. You know, you're going to end up with universe with particles, but there's not going to be anything, no higher ordered structures like stars and planets and life.
That's really fascinating. In fact, when I first heard these sorts of arguments, I was really struck because it is remarkable that gravity is the weakest force, but it accumulates. It gets stronger and stronger as lots of mass comes together. Electromagnetism, or the electric force, is much, much stronger, but it cancels itself out, like plus and minus charges cancel each other out. And that qualitative nature is essential. I think that's just a brilliant argument. Now, you also mentioned quantum mechanics, which is one of my favorite examples. Could you talk about that?
Sure. So it's also one of my favorite examples, because what's so interesting is historically, classical physics was your Newtonian physics, not going back to Aristotle, just Newton. And according to Newtonian physics, atoms really shouldn't be stable because an electron should really spiral into the nucleus and atoms shouldn't exist. And that was one of the major problems with classical physics. And it was really quantum mechanics with really the bizarreness of quantum mechanics, certain allowed orbits of the electrons through the uncertainty principle, which obviously we don't want to go into that too much here, but it's the weirdness and the strangeness of quantum mechanics, which allowed atoms to be stable. And that was, in a sense, what the Bohr model, the atom, we're trying to explain is how are atoms stable. But that just illustrates the point that nothing logically wrong with Newtonian physics. It just happens to be the universe doesn't work that way. And it's a good thing it doesn't work that way, because there'd be no atoms and molecules in life if the universe didn't work that way. And then it shows you the reason why the universe works by quantum mechanics and not Newtonian physics is because there's a purpose to these laws. They're trying to produce atoms and molecules and stars and planets and life. And that really, it's another element, just the very laws of quantum mechanics shows you that there's a purpose to these laws to achieve a complex universe.
One of the aspects of quantum mechanics that really struck me was the nature of what's called the Schrodinger equation. And for our listeners, I encourage you just to look online what the Schrodinger equation is. And it's what governs the probability that various particles would be in certain positions or have certain momentums. And it actually has an imaginary number. And an imaginary number is like the square root of -1. And that's weird. I mean, it's really strange for a physical equation of reality to have an imaginary number. But if it didn't have that imaginary number, you wouldn't have what are called these orbitals. You wouldn't have stable atoms, which I think is phenomenal. And that alone points to design in a beautiful way. But could you please, in your podcast, you talk about the implications of all this. So could you share what you believe is the correct explanation for the nature of the laws and why they are the way they are?
Yeah, sure. So just, I guess basically reiterating the argument here is that scientists started with a mystery, is you have these laws, and it's a question, bothered scientists, why these laws as opposed to any other laws? And as far as physicists could tell, there's many, many, many sets of laws, infinitely many possible laws could have existed. And we didn't know why do we have these laws as opposed to the others? And they were looking and trying to find it. But when you think into it and we realize the more we learn about these laws, we see how special they actually are. We see how their features are such, as Aaron described these examples, and as you mentioned, Brian, how the features of the laws are necessary for the purpose. They're not nothing special about them mathematically. There could be a lot of laws mathematically, but they have a purpose. They're objective. Only these laws that have the capacity to result in a universe like our own. And we're saying is like that indicates an intelligent cause. As we said, an intelligent cause is a cause that acts with a purpose, that selects the proper components or numbers, or in this case, the qualitative laws, with a goal in mind, and is able to select from this set of infinite possible laws to select a particular set of laws which has the ability to produce a universe like our own. That's really a mark of intelligence. And that's why we think is the discovery, the unique nature of the laws points to a teleological cause, a cause which is intelligent. We think that's the clear implication of the nature of the laws.
Now, how does your previous argument for the fine tuning relate to your current argument? My understanding is they're somewhat complementary, but then they achieve different purposes. How would you describe that?
So they're really independent arguments, completely independent. We on our podcast, the first 5 episodes of our season was about fine tuning. We didn't discuss at all the design of the laws. Um, and that's just, again, has to do with quantities. And this, you can completely ignore the phenomenon of fine tuning with the constants and the quantities and just discuss the the structure and the qualitative nature of these laws, and to show how gravity, quantum mechanics are necessary in order to have a complex universe. And basically, each argument works independently on its own. They each have their strengths and weaknesses, but they work independent. They're not contingent on each other, but they do complement each other in the sense that if you are really convinced by the fine tuning argument that the universe has an intelligent cause, who selected the specific numbers for the constants of nature, then it's further very compelling to argue that the explanation for the cause of the qualitative nature of the laws is also going to be the same intelligent cause that fixed the qualitative nature. Because after all, we're dealing with the laws of physics, and they have qualitative aspect and a quantitative aspect. And if you're convinced by one of these arguments more so than the other, that is really complements each other and makes it more convincing that the other one really is also the right solution for either the constants or the qualitative laws is an intelligent cause.
Hmm.
I just want to add, this isn't exactly the question you're asking, but there's a third line of reasoning that completes the picture, which is besides for the qualitative laws of nature, which indicate an intelligent cause, and the quantities in those laws, the fine tuning which indicates an intelligent cause, we have a third argument which relates to the initial conditions. And that's the initial conditions of our universe, the low entropy initial conditions, which we develop in two other episodes, which basically is totally independent, the third line of reasoning, which exists independently, but together the three combined show all the features of our universe, the qualitative laws, their numbers, and the initial setup of our universe all come together to point to an intelligent cause. And maybe at a different time we could discuss that.
Right.
Oh, that's an incredibly powerful argument. There's sort of these three independent lines of reasoning, all pointing back to a mind involved in our universe.
It's not just like there's three separate arguments. It's when you like analyze the universe, there's like these are the three components of the universe. You have
Hmm.
the qualitative laws, the quantities of the laws, and the initial state that the universe began in. If you have all those three things, you get a universe. So it's really when you analyze the universe in terms of all its different fundamental components, you realize there's design and order and fine tuning built into it.
So what you're doing is you're saying that comprehensively every aspect of our universe, the structure of the laws, the actual values of the constants, and the initial conditions, every aspect points to design. So it's both comprehensive and extremely rigorous. The argument that's
Right.
really beautiful.
Right, exactly. We just, maybe your listeners would appreciate this, but we had an analogy of a chess game. And you think the game of chess is maybe designed in a way which is optimal for a good game. And you could talk about in a game of chess, you could talk about the qualitative nature of the pieces, about how they move. Let's say queens move diagonally and the castle moves straight and whatever, however the pieces move. But then you could also talk about the quantities, about how many spaces they move. So pawn will move one or two spaces and the queen will move as many spaces. That's the quantities. And then you also have like the initial setup of the game. Even if you have all the pieces moving, the qualitative nature of the pieces and the quantities of them, how does the game start? And we know that there's a special way that the game starts. That's the initial setup. And the different features of the game of chess, let's say, are designed to produce the greatest game. So likewise, you have these different components of our universe, and all the different components come together and indicate this idea of an intelligent cause behind it all.
And that's a really beautiful analogy because one aspect of the analogy that's really brought up is how none of these aspects of the game could be generated through natural processes. No one's going to go into a chemistry lab, run a chemistry experiment, and then suddenly the laws of chess pop out. It's something that's abstract and
Right.
prerequisite.
Yeah, you're
That's
dealing
really
with like
that's
fundamental physics, where it's like the basis of the pyramid in science. There's nothing before fundamental physics other than some intelligent cause. You know, as opposed to, I guess you're alluding to chemistry and biology. They're more derived from physics. That's why you have those issues that come up.
Let me conclude our interview with one last question. Now, you've presented three profound arguments for designing the universe, and particularly we focused on two. One, which was that the laws of nature, their very structure, had to be designed for life. And two, the constants or the details about those laws had to be designed for life. Could you share the advantages and disadvantages of both lines of argumentation?
Yeah, it's important to be like to be honest and to be aware of what the strengths and what the weaknesses of each argument is. So in terms of the advantage of fine tuning, where you're dealing with quantities and numbers, as opposed to this argument from the qualitative nature of laws, is it's fairly obvious why you can't just say the constants in these numbers are just brute facts of reality. They must exist. They're fundamental existences. Because nobody wants to say that a number like 1 over 137.039999139, it's a defined structure constant, or a number cosmological constant, 120 decimal places. Nobody wants to say that's just the way it is. It's a brute fact of reality. It's not compelling. It's not plausible that that reality is that way. But when you come to the laws of nature, general relativity, quantum mechanics, they're really beautiful, symmetrical, simple laws, and there's an elegance to them. And many physicists will find this, it's much more plausible to say that's just the way reality is. Nobody made it that way. Gravity is the way it is. There's no reason. It's not to produce stars. It's not to produce planets. It's just because it is that way. And it's because there's something beautiful and compelling about a qualitative law that it's almost somewhat satisfying to a lot of physicists to say that's just the way it is. As opposed to when you deal with numbers, that nobody wants to say it's just some arbitrary, complex little number is the way it is. So a lot of physicists are just saying, "Look, this is just the way it is. Stop asking questions." And it's a better answer than it is vis-a-vis fine tuning to say that. But the strength of this argument is because it's not really a very good answer just to say that's just the way it is. It doesn't have to be. There's no logical reason why gravity must exist. There's no physical reason why electromagnetism must exist. None of these things are very compelling, and you really do want to have an answer to why these laws. And and there really is no other answer other than the multiverse on a supercharged multiverse. Maybe that's what we'll talk about next time. But it's Max Tegmark's version where every single possible law of nature exists and everything possible happens. And it's the multiverse is not a very good explanation for fine tuning. We discussed that on the Physics to God podcast, why it doesn't work for fine tuning, but it completely blows up and just destroys itself when it's trying to answer the design of the laws. And it utterly fails in an even more explicit way of why it goes wrong. And it really just doesn't work at all. So in terms of the design of the laws, the multiverse is just simply really not a viable option at all. And that's why most physicists don't even really consider it that much, the multiverse. So you're really stuck with no real answer other than saying that's just the way it is.
Just to add one more point, I think one more strength of the fine-tuning argument over the design of the laws is that part of the way you see the intelligence is when you take these quantities and you see what would happen if the quantities were different. And we could take the laws and we could change the quantities and model and see what exactly would happen. And for each one of the fine-tuned quantities, we could see how we wouldn't have atoms, how we wouldn't have stars, how the universe wouldn't work, how there wouldn't be structure and order and complexity. And because the numbers, with the laws being fixed and the numbers changing, it's very easy to model and to see how these numbers are special. When it comes to the qualitative laws, the argument is that these laws are special because they result in our unbelievable universe. But what about other laws? Well, what are these other laws? There's an infinite set of other laws, and it's very hard to rigorously consider what other laws could have existed. And I don't know, maybe random laws would just happen to produce an unbelievable universe. It's like, it doesn't intuitively seem that way. They seem to scientists' intuition is these laws are special and they're unique. There's something special about them. But to make that argument rigorous is hard because you're dealing with an undefined set of qualitative laws of the universe that the universe may potentially theoretically operate with. So that's why, in some sense, the fine-tuning argument could be made more rigorous because of it just deals with the quantities.
Oh, thank you. That was very helpful distinction. Well, that concludes the first part of our interview. And I encourage our listeners to listen to the second part of the interview after you hear this one, because what we'll do is we'll continue the conversation by dealing with what is only one of the only attempts to respond to this very powerful argument. But as we'll see in the next interview, it's not a very good attempt. So Ellie and Aaron, thank you for your time.
Our pleasure, Brian.
Pleasure.
For ID the Future, I'm Brian Miller. Thanks for joining us.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.